Hello everyone, this is Wilson. Today I'm going to talk about this limit problem involving the absolute value. And if you have seen my other video, usually for this kind of limit problem, we are going to break this limit problem, this two-sided limit problem, into two one-sided limit problems. And as you can see here, because x is approaching negative 3 and there is no direction indicated here, so that's a two-sided limit problem. And for this problem here, you can see that if we plug in the negative 3 into the x, we are actually getting 0 over 0, which is something that I'm not going to show because it's quite obvious right here. The problem is that we cannot really directly cancel out the x plus 3 and the x plus 3 right here because this x plus 3 in the numerator, it's inside the absolute value. So what are we going to do here? Let's consider the two one-sided limit problems and see how what answer that they will give you. Okay, so what we are going to do is that we are going to consider this limit when x is approaching negative 3 from the left, and then we have this function right here. So I'm just going to copy the whole function down, and then so we have x plus 3. Okay. Now, when x is approaching negative 3 from the left side, that's really just saying that x is less than negative 3 right here, right? It's not exactly negative 3. It's getting closer and closer. And all those numbers that you're that you take for the x value, it's going to be less than negative 3. And so in this case, what happens is that when x is less than minus 3, then what happens to x plus 3? So just think about this. When x is less than negative 3, if we look at that, let's actually just do some scratch work right here. X less than negative 3, if we are approaching negative 3 from the left side, that's really just taking the x values like negative 3.01, okay? And then getting closer, negative 3.005, okay? And then negative 3.001. And then if you just keep moving closer, like the 3.0005 and so on, right? Just keep getting closer and closer. And no matter which number that you put in there, right? See what's going on here when you plug that any of those numbers into this x right here and you add the 3, you're actually going to be getting a negative value for the x plus 3. Okay, so that's what happens. So when you rewrite this expression, okay, when you rewrite this expression, you are going to be getting a minus and then x plus 3 here. And then you may say, why did we do that? It's really because of this. Remember, when you take the absolute value of a real number, you are going to get a non-negative number, right, as an output for the absolute value function. So because whatever quantity that you have inside the absolute value, the x plus 3, they are all negative. And so when you take it out, if you simply just remove the absolute value, what happens is that you are going to be getting a negative number, but that cannot be the output for this absolute value. So in this case, you need to put a minus sign in front of it to negate that quantity, so that now you are getting a non-negative value. In this case, it will be positive because x is not exactly negative 3. Okay, so you get that. And then you may say, what about the denominator here? The denominator is simple. You just copy, right? Because there is nothing to do for the denominator. And so from here, it's still 0 over 0. But remember that now we have no more absolute value, so we can cancel them. So let's cancel them right here. The top and the bottom becomes a 1 with the minus sign. So what is that limit equal to? That's equal to negative 1. Okay, so the left side limit for this function is negative 1. Now, we need to consider the right side limit. So let's look at this one here. So let's say we're approaching negative 3 from the right side. That means all those x values that you are taking to approach the negative 3 from the right would be greater than this negative 3. So let me copy down the function first. Okay, let's look at all those values right here, which is that when x is greater than -3 and it's approaching -3 from the right side, what happens is that you are going to take those values like -2.99, right? And then -2.995, -2.999, right? And then -2.999, and then it doesn't have to be a 5, right? It can be, let's say, just take a 4, okay, and then just keep going from there, right? I'm just using 5 right here, but you know that it doesn't have to be 5, right? It can be some other numbers. Okay, so as you can see, no matter which number that you plug in from this list, let's say if you plug in -2.99 right here, 3 minus 2.99, you are going to be getting a positive number. And actually, even if you plug in closer numbers to here, then you are still going to be getting a positive number inside the absolute value. So in that case, we know that no matter which x value that you are plugging in, you are getting a positive number. And so you can simply just remove the absolute value, okay, without doing anything, unlike the previous one-sided limit where we put a negative sign in front of the expression. We do not need to do anything here. Just remove the absolute value. And then the bottom, just copy. And do you see what's going on here? We can do the canceling here. We can cancel the x plus 3 into a 1 and a 1 here. And so what is our final answer? Our final answer is just 1. Okay, so basically we are done with this problem. Then you may say, how do we know that we are done? Because we already computed the two one-sided limits and they're different, right? They're not equal. And what can you say about the two-sided limit? Then this two-sided limit does not exist. Okay, so we say that since, again, so we need to write this down right here. So since the left side limit is not equal to the right side limit of this same function, what can we conclude? We conclude that the two-sided limit actually it should be -3, right? I think it's missing the minus sign for this one right here. It should be -3, so that's missing a minus sign right here. Let me redraw that -3. Okay, the two-sided limit does not exist. And then we're finished with the problem. There's one thing that I want to point out right here is that sometimes when people are writing down this conclusion here, they will say it's actually wrong to say this, right? So don't do this one. So sometimes people will say, since -1 is not equal to +1, we conclude, right? The rest is the same stuff. The rest is the same stuff. But do you know what's wrong by saying this? We actually have to say that, but we cannot really say this because we know that -1 is not equal to 1. So just because -1 not being equal to 1 does not show that this limit does not exist. We have to claim that this left side limit is not equal to the right side limit. That's why that this two-sided limit of the same function does not exist. But this cannot really imply, cannot be used to imply that this two-sided limit does not exist because -1 not equal to 1, that's, we all know that that's true, right? So that's not going to, that doesn't prove anything here. Is that okay? So it's wrong to use this reasoning. You got to use this one, okay? But I will actually often see people writing this argument here, even though I know what you mean, but it's not correct to say that. So you gotta write out the whole limit and say that they're not equal so that the two-sided limit does not exist. Okay, so that's it for this problem. Make sure that you don't do this. If you like this video, please give me a like, subscribe to my channel, and then share my videos to others. It will give me support to make more videos. If you have questions or have a topic that you want me to talk about, please leave me a comment. I will try my best to see if it's possible for me to make those topics. Thank you for watching this video and your support. I will see